Hello everyone, I am Professor Rashmi Panelkar. Now start the lecture for transmission line protection. So in this unit we have to cover overcurrent protection for the feeder using the directional and the non-directional overcurrent relays. Then what are the different type of protection scheme we can use for the transmission line protection. Then introduction to distance protection. Again, it is classified into the three types: impedance, reactance, and the more relay. Then what is the meaning of the PLCC and what are the advantages and what is the use of this PLCC? Then three-step distance protection. It is classified into the distance protection. Then what is the arc resistance, effect of the arc resistance, then power spin performance for the distance relay, and last one is the realization of the distance relay. That means the comparison in between the impedance, reactance, and the more relay using the numerical relay. And in this relay, we have to cover the flow chart for and the block diagram. We have to cover the how the numerical relay it is working. Then last topic of this unit is the wide area network. So before starting the transmission line protection, we have already covered the transformer protection and the alternator protection. So in this transformer and the alternator protection, there are the different type of the abnormalities occur in the system. So in the transformer, that means transformer, it is nothing but it is the heart of the power system. So the power transformer is a major equipment, so it has again abnormal conditions occur in the system. Similarly, overload, earth fault, through fault, then large internal faults. Large internal fault, that means face to face fault, face to ground fault, and below oil level fault. Then the high fault in the tap changer. So which type of protection employ for this abnormalities for the transformer we have already done. So basically there are the differential protection we can use for the transformer and alternator also. So similarly for the transmission protection. So what is the meaning of the transmission protection? Why the transmission protection? It is very, very important. Yes. So the transmission line have a large length and it is exposed to different atmospheric condition. So the chance of occurrence of the faults are more. Then which type of fault occur in the system, like a overhead line of the transmission line? So fault in the overhead transmission line, that means like a feeder lines and the transmission line are of the much bigger length than hundreds of kilometer, and these are exposed to the atmosphere, so that these are the chances of occurring fall due to the wind, storms, then ice flashover, lightning falling trees, lightning falling trees, then objects, birds, dirt, then dust, and so fault. And this type of the fault may be short circuited, open circuited, and earth fault, lightning, etc. So such a type of the fault occur in the system. So what is the meaning of the protection of the transmission line? What is the meaning of the protection of the transmission line? That means we have to use the some magnitude for the transmission line, uh, such a type of distance. That means we have to use the distance protection, because the transmission line, it is nothing but the hundreds of kilometers, is much bigger length is there. So the distance protection, it is a very, very important protection. So then the next is nothing but the 1 minute, I will just wait. Yes. So the time graded overcurrent protection. Then second one is the differential pilot wire protection, and third one is the distance protection. So these three type of the protection we can require for the transmission line. Okay, so in the transmission line, we can say that the main purpose of the transmission protection relay are to identify the fault of the location. That means these relay are also used to identify the type of the fault in the transmission line. So it is based on the different type of the protection. So why the protection is very very important? Because uh, as you already know, the real purpose of the transmission line protection is to detect the fault or abnormal operating condition and to initiate the corrective action. So the protective relay must be able to evaluate a lot of parameters to choose to establish right correction action, so that it is a very very important transmission line protection. Then how are the transmission line protected? Such type of I already explained. The distance measure the impedance of the line. That means using the voltage applied to the relay and the current applied to the relay. That means when the fault occur in the line, so current rises significantly and voltage collapse significantly. So in the magnitude of the current and the voltage, uh, it is protected through the transmission line. Then why the feeder should be protected? Feeder, that means it is nothing but the feeder protection are more exactly protection for the overhead line and the cable. So it is the most commonly used type of the protection, because the protection has ensured that the power grid and continues to the supply energy. So when the fault occur in the system, any system, that means in case of the fault when occur in the system, so it must be prevented from the spreading to healthy parts of the network, so that feeder also should be protected is there. So which protection scheme it is used for the transmission line? It is nothing but the POTT scheme. That means it is usually used for the high voltage line protection against the fault in the areas with the coordination and the power stability issues. So three-phase fault is most severe type of the fault that can be occur, and fast tripping at the high voltages is paramount for the personal safety to avoid the equipment destruction and the fire also. So the main purpose of this protection, that means it is protection is any measure taken to guard a thing against damage caused by the outside forces. Suppose protection can be provided to the physical object including organism and to the systems, and to initiatable things like a civil and the political right also. So this is nothing but the purpose of the transmission line to carry the electric energy from one point to another in the electric power system, so that they can carry the alternating current or direct current on the system, can be combination of both also. So the electric current can be carried by either overhead and the underground also. So in the transmission line, so in the transformer, uh, you already seen in the substation. So such a differential protection we can use for the transformer. So such a type of the panel is there. So the out it is nothing but the 22 by 11 kV substation is there. So the outgoing is nothing but there are the 22 feeders are there and three outgoings are there. That means the three transformer we can connect with the 22 feeders. So this is nothing but the energy meter, like it is show the what is the kVAR, what is the current, what is the graded time system for the feeder. In there are the different type in a outgoing transformer we can connect with this type of the panel. So differential protection, it is nothing but the uh, related with the current magnitude. So this type of the relay we can connect also with this 22 kV uh, Rohit Tantra. It is also in Marathi Rohit Tantra. That means it is called as the control panel for the transformer. So this is for the transformer 1, this is for the transformer 2. So you can see here, this is for the cos phi, what is the power factor. So these are the analog meters we can connect here, and uh, according to that, this is nothing but the circuit breaker alarms also there. So it will be trip when the fault occur in the system. So it will be show like that. So similarly for the transmission line panel also look like there. I don't have the image for the transmission line protection, so I can show you right now. So So this type of the protection relay for the similarly for the distance relay for the transmission line, we can use for the Ashida numerical three-phase distance protection relay for the transmission line. So it is look like that. Then the line of the protection, we can say that generating station, then transmission line, then substation. So this is the process for the generating, transmission, and the distribution system. Then this is nothing but the overhead line for the transmission, 500 kV, 230 kV, 138, 69, 7 to 13 kV. So similarly, this is nothing but the transmission, that means the generating to the distribution. We can connect the transmission line, and energy will be supplied to this transmission line. That means it is a very, very important part of the electricity. That means there are the very serious fault will be occur there. So the protection is very, very important. So it is nothing but right now we can cover the 2 points are there. First is the time graded protection, and second one is the current graded protection. So basically you know about what is the time graded protection. So time graded protection, that means it is nothing but what is the definition for the time graded protection. So the time graded protection uh, is nothing but the line or the feeder. It is divided into the two sections. Okay, this is current graded and this is the time graded. So for the time graded protection, it is classified into the three types: radial figure, parallel feeder, and the ring main system. So using the definite time relay, that means the definite time relay, instantaneous relay, very inverse instantaneous relay, it is again classified into the overcurrent protection. So in the overcurrent protection, that means the magnitude is nothing but their overcurrent. Okay. And the second one is the time. That means you have to explain your characteristic with the current versus time. So it is the magnitude of the transmission line. That means it is nothing but the current. And the time when the fault occur. That means you have to set the circuit breaker time. You have to set the relay setting is there again. So it is related with the definite time overcurrent relay. It is, but in the feeder system, there are the three feeder system: radial feeder system, parallel feeder system, and the ring main feeder system. So basically, these three type of the feeder system, it is classified into the time graded overcurrent system. That means you have to uh, classify it, that means you have to classify this time graded overcurrent system into the radial radial feeder, parallel feeder, and the radial feeder, parallel feeder, and the ring feeder system. Then the first topic is nothing but there is the time graded system. Okay, so in the time graded system, it is nothing but what is the time graded system? What is the definition for the time graded system? So it is the scheme of the overcurrent protection. I already told you it is nothing but the magnitude. That means the current is the magnitude for the transmission line. So it is the scheme of the overcurrent protection in which the time discrimination, uh, it is the time discrimination is incorporated. In other words, that means we can say that ki other words, that means the time setting of the relay, it's so graded, that is the event of the fault smallest possible system is isolated. I will repeat again. The time setting of the relay, it's so graded that in the event of the fault smallest possible system is isolated. So here the definite time overcurrent relay that are used whose operating time is independent of the fault current. Okay, so the total line is divided into two different sections. That means second two different section, and each section is provided with the definite time delay. The total line is divided into the two different section. So each line is provided with the definite time system. So this is nothing but the radial feeder system. That means here the application of this time graded system apply to the radial feeder. That means this time graded overcurrent protection, it is the application we can use for the radial feeder, ring main system, parallel feeder system similarly. So for the radial feeder system, it is used as a application based. That means we have to use the main characteristic of this radial feeder, the power can flow. So this power can flow one direction to only one direct. Power can flow only one direction. That means generating or generating or the supply and the load end. That means first end is the generating station and second one is the load station at the end. This is the starting end and this is the ending end. So it is desired that is the smallest foot of the system, part of the system that should be isolated. So we can isolate here when the fault occur in the system. Okay. So in the case of the fault, suppose there is the in the case of the fault. That means this is the case of the fault. So when the case of the fault, so here the total line it is divided into the two different section and each section provided with a definite time value. That means there is the relay 1, relay 2, relay 3 and the relay 4. So it is nothing but in the three sections are there, section A, section B and the section C. And to achieve this objective to the smallest possible part should be isolated in the case of the fault achieved. This is operating time of the relay is adjusted in order to far end of the feeder. That means when the fault occur in the system, when the fault occur, when the fault occur in the system, that means you have to achieve this objective. That means you have to achieve the smallest possible part should be isolated in the case of the fault. In the case of the fault, to achieve this is operating time of the relay is adjusted in order to far end of the feeder, far end of the feeder. So the relay is nearest to the end. The relay is nearest to the end of the line has minimum time setting of the value. So while the time setting of the other relay is successively increasing the value, the load end of the relay value, it will be the smallest value, but the value of the relay will be increasingly, successively increasingly towards the source. That means the relay nearest to the line, the relay nearest to the end of the line has minimum value, minimum time setting for the value, while the time setting in other relays successively increase towards the source. Why this is here? Because near the source and end is the maximum. It is nothing but a 2.5 second. Okay. So similarly, we can say that 2 second, 1.5 second, 1.2 second, and 0.8 second. So minimum value, it is nothing but there. The maximum value is nothing but there is the 2 second. So minimum internal time to adjustment which can be allowed for the two adjustment circuit breaker depends upon the own clearance. So the time small for the safety margin. So let us assume that if the fault occur to the near to the load center, okay, if the fault occur near to the load center, similarly, I will repeat again. There are the four types of the relay we can connect with the generating station to the load end. Okay, this is the substation A, substation B, and the substation C. That means it is nothing but when the fault occur in the system, that means substation A to B, then B to C, and beyond C, like that. So which relay will be occur firstly and why? This is the question here. Okay. So let us assume that the fault occur in the system at the load end, nearer to the load end. So in that case, so the D will be, that means so that the relay C will be operate because it is the smallest operating time. Because it is the smallest operating time. Because relay 1 has a 2 second, relay 2 1.5, relay 3 1.2, and relay 4 0.8. So the minimum so the this relay operate because it is the smallest operating time. again the desirable operation, because it is expected that possible part of the system should be isolated in the case of the fault system. So this is nothing but the operating time and the distance which will be follow like that. That means there is nothing but, similarly, this is the supply end and this is the load end side. So the current value will be the decreasing from source into the load end. So we can say that the time when the fault occur nearer to the load center, the smallest value will be the occur. That means the smallest relay value will be the occur in the system. So this is also same diagram is there. So you can refer this also and this also. Okay. So this is the time versus distance. It is nothing but the characteristic like that. Though the entire feeder is sectionalized like A, B, C, and the C, D. So the definite time relay are used to individual section, which give the trip signal to the respective circuit breaker. With respect to circuit breaker, suppose the relay 1, suppose the relay 1 has a operating time. Suppose the relay 1 has a operating time, that means it is nothing but there is a 2 second. Relay 2 has a 1.5, relay 3 has a 1.2, relay 4 has a 0.8 second. So relay 1, so the relay 4 has a operating time is nothing but the 0.8 second. Then for the R3 1.2, R2 1.5 and 2 second. So if the fault occur in the section of the C to D, that the section will be isolated through the 0.8 second by the relay 4 and the circuit breaker. This is nothing but the substation B, C, A. It is nothing but your circuit breaker. That means relay will sends the fault current and then trip signal to the circuit breaker. So the remaining relay will not operate. Okay. So the remaining relay will not operate because their operating time is higher. So if the relay 4 and the circuit breaker, that means the substation C, fails to operate even after 0.8 second, then the relay R3, that means 1.2 second, operates after 1.2 second, and then the substation B circuit breakers to open and so act as a backup protection is working like that. So in this way, remaining this relay will be operate. That means when the relay 3 it fails to operate, then the relay 2 will be the operate here. And if the fail relay 2 is operate, then the relay 1 will be the operate here for the after the 2 time plays the part in the time of the 2 second. That means that there are some drawback for this system. That means if the feeder is having the large length or more number of the section, so the operating time is near supply site point is more. So the for our case it will be the, so the for our case it will be the 2 second, which is the appreciable. But if the fault, say line to ground fault, occur in the section nearer to the transformer or any source, in that case amount of fault current will be more because the impedance of the line is less. Because impedance line is less. So this type of system is not suitable for the ring main system or the interconnected system, and suitable, but it is suitable only for the radial lines which supply at one end only, at the supply when the supply at the one end only. So not suitable to coordinate also, and need the changes with the new connections also. So not suitable for the long length line if the because the fault occur in the system and the relay will be not operate in the long section, so the healthy section also the becomes a unhealthy section is there. So the continuity of supply cannot be maintained at the receiving in the event of the fault. So ideally operating time should be less for the more amount of fault current, and if the feeder is having the large length and number of sections are more, so the condition cannot be satisfied. So the time credit principle, it is applicable where the impedance between the substation is low and the feeder length is less. Similarly, we can say that Just wait. Similarly, we can say that time graded principle, it is applicable where the impedance, that means Z, between the substation is low. Between the substation is low, the feeder length is also less. Okay, that means in addition to this relay operating time, this circuit breaker is operating time should be also considered. So it most of the cases it is necessary to limit the maximum tripping time to second. Thank you.